Hey, welcome everyone to the Astronomical Society of Edinburgh. We are online, somewhere in the orbit around the moon, I think. And this is what we've got coming up tonight. So I've got a few slides before we get to the main event of the night. I've got some news from us, um, what we've got coming up over the next few months. And then our main event of the evening is from Mary McIntyre, and she's doing part 2 of her History of Women in Astronomy part 1. If you saw part 1, it was really, really interesting, really good. This is the follow-up on that. You can find that talk on our YouTube channel as well if you want to catch up on it. At the end of the meeting, we'll stay online for a few minutes and go over live to our observatory in Spain, because the moon is very close to the Pleiades tonight. And we'll see if we can observe that live. We'll keep YouTube on as well if you want to watch that. Might be a bit of a challenge getting the exposures right, because the moon is very bright, and the Pleiades, although they're bright, are not as bright as the moon. So we'll see how we get on with that. A lot of new members again over the last month. So welcome to Paul, Michael, David, Dorothy, Simon, Neil, Chris, and Lawrence. If we can unmute and welcome them in the usual way, please. And membership is now up to a staggering 212, which keeps getting higher than any other time in our 100-year history. Although we know that that will drop very shortly, because the end of February is the cutoff point for renewing subscriptions, and we always have a small drop there as well. Okay, a few news items. As I've mentioned before, we are running a telescope help shop, and this is on the 16th of March in Edinburgh. It is aimed at beginners who want to learn how to use their new telescopes, or a telescope they've had for a long time, don't know how to use it. They're always really, really popular. People always seem to really enjoy them. And we still have a few places left. ASC members, it's free. But for non-members, it's £5, and you'll find a link to the ticketing site on our website, the event document there. But it is worthwhile if you haven't worked out how to use your telescope or want to learn how to use it better. That's a great place to come. And the moon will be up if the weather is clear, so you will be able to use them to look at that. Our centenary event, this is our 100th year, on the 15th of October 2024. We will be 100 years old, and we are having an event to hopefully match the 100 years ago at the Royal Society of Edinburgh. This event is for ASC members and hopefully their partners, if we've got the space for the numbers. And the Royal Society of Edinburgh in George Street in Edinburgh. And we have confirmed that Professor Chris Lintott of Sky at Night fame and many other fames will be our guest speaker. And Chris will also be doing various other things at the Royal Observatory at Edinburgh while he's up here, and I think he's giving a public lecture the next day as well, so people can pop along to that and see it there as well. And he has a new book coming out, so there'll probably be some book signing going on as well. More details for members and ticketing will follow in a few months' time. But it should be a good event, so put it in your diaries and make sure you're able to attend that. Earlier on in the month, we had to cancel our meeting at short notice, unavoidably, and that has been now rescheduled to the 5th of April. But instead, we all just popped online to our telescope in Spain and had quite a good evening, just zooming around the universe and taking pictures of some very nice things. And these are the things we observed live on the night. These are the actual stacks of images, galaxies and clusters, and nebulae, and it was a really good evening. I think everyone enjoyed that. So that's one of the benefits of having a remote observatory in Spain. So as our remote telescope, which we'll use at the end of the evening, we are still working on it. It's almost configured, finally configured, and it has been for a while. But the large telescope is almost there now. We're going to get a new, larger, better coma corrector and a larger focuser as well. So this should, in inverted commas, be the final step, but it is already working well for some targets and certainly on science data as well. Our wide field diranoscope is available and working well, and we'll be using that tonight as well. We now have both filter wheels working independently because they were conflicting before. And we have various projects that we are already working on that are up and running. We're obviously looking for ideas of what you want to observe, what projects you want to run, and we want people to get involved as well. I think it's the best way of getting people involved in using a remote telescope. This is what it was looking like today at the observatory. And it's a nice sunny day, and that's our telescope over there in the background. So as I said, we do have some projects that are running already, which you'll know some about. So we have a Comet project running. We're currently imaging a couple of comets tonight. We have a meteor project running that Radim is coordinating. Pat Devine is coordinating our asteroid project, and we've just started an eclipsing binary project. We also, as a group, contribute data to the HOIS project as well. I always think if you give it a name and a logo, then it's going to work. So that's why I've done that. We do have some ideas for some new projects we're going to hopefully run. Moon project, maybe. I know our telescopes aren't set up for lunar and planetary stuff, but we've shown that we can actually do some very nice stuff with a larger telescope. We're going to be doing something with exoplanets as well, maybe the Exoclock project, because our Merrill scope will be really good for that. Another possibility is discovering planetary nebulae. Peter Goodhue gave us a talk about that last year, and that's one that we've been speaking to him about taking part in as well. And of course, we'll keep on taking pictures of the most beautiful objects in the night sky as well. And as everyone in society seems to have bought a smart scope at Christmas, we have been doing some work on getting to use these smart scopes on the project as well. So we know we can already use them for the HOIS project. We think we'll be able to use them for various variable star projects as well, and many more. So don't feel left out. And it's a great way of complementing what we do with our telescopes in Spain with your own data from Edinburgh. These are the usual ways of staying in touch with us. Everything we do is on our website, Facebook, Twitter, or X, and all the videos of our meetings can be seen on our YouTube channel. We have lots of images on our Flickr groups, and we're also now on the Blue Sky social channel as well. So over the next couple of months, we have a members' night on the 1st of March. That will be a number of short presentations from ASC members. That won't be on YouTube. It'll be in the Augustine United Church in Edinburgh. So visitors are welcome to drop into that, and it'll be on Zoom as well. We have our Imaging Observing Group meeting for members only. That's on the 6th of March online. And the next online only talk will be on the 15th of March when Steve Tonke will tell us about how the universe is trying to kill you. The 5th of April is the reschedule one from earlier this month from Professor Martin Hendry about gravitational wave astronomy. And on the 19th of April, an online only talk, The Secret Life of Stars, from Sandra Brantington of the BAA. So that's what's coming up. Enough from me. I know this is what you're here for, is to listen to Mary. So Mary, it's over to you now. So thank you very much.
Thank you, and good evening, everyone. I'm really happy to be bringing part 2 of my History of Women in Astronomy talk to you. When we left off last time, you'll probably remember that I kind of more or less stopped when we talked about this lady, Caroline Herschel, still my favorite person from the whole of history. And the work that Caroline did, although as we saw in part 1, she was not the first female astronomer, but she helped to change the landscape and make it easier for women to kind of find their way professionally doing astronomy after her. And once we kind of got to the 1800s, there were so many more women that were doing really valuable work that it's impossible for me to talk about all of them. So I'm trying to cram in as many as I can. So it's a snapshot. They all did way more than I'm going to be able to talk about in the time that we have. Otherwise, I'll keep you here till midnight. So I'm going to zoom through some of that. And just again, a reminder that like the social standing that women had at the time was seen and not heard. So it was very difficult for the ladies to get an education. It fell to male relatives or friends of the family to educate them, or they just did it themselves. And that's kind of how it had to go down, particularly here in the UK. It wasn't quite as bad in other places, but I will talk briefly about the education when there's a relevant point of that coming up. So yeah, I still love Caroline, but there are so many more women to talk about after Caroline, so I won't allow myself to get distracted by Caroline and instead move on to Mary Fairfax Somerville. Many of you, I'm sure, will be aware of Mary Somerville, particularly in Scotland. So she was actually born in Jedburgh, spent her childhood in Fife in Scotland, and she had a father that was very supportive of educating his daughter, and he basically felt that she should receive the same education that her brothers did. She found that when she was at school, that the gender inequality with regard to education was really stark, and she was very frustrated by this. She had a thirst for knowledge. She wanted to learn science, and she just wasn't able to do that at school. And at school, boys were taught Latin, and most science at the time was written in Latin. So if you couldn't speak Latin, you would struggle to read journals and papers of scientific nature. The girls that went to school were taught reading in so much as being able to read the Bible, nothing more. It's kind of like, right, you can read the Bible now, that's it. You don't need to be able to read any further. And she actually had family members that would come to visit and was like, oh, look at the state of her needlework. You need to get her off to night school to be better at needlework. She wasn't even the slightest bit interested in needlework. She wanted to learn science. She ended up kind of, there's quite a few quotes from her life, and she stated that she was really annoyed that her turn for reading was so disapproved of, and felt that it was unjust that if a woman was given a desire to acquire knowledge, why was it so wrong for her to acquire it? So she really couldn't kind of rationalize those two things. Somebody else was making the decision for her that she wasn't able to get that education. And she also really resented the fact that there were all these privileges of education that were basically given lavishly to men and yet denied for women. And she was really very, very strongly disapproving of this situation. It's kind of, if a woman wants to learn science, she should be allowed to, but she couldn't. Now, when she was 13, her brother was actually having lessons in maths, and she would listen to what the tutor was saying and pick up tips from there. Her brother's tutor would give her tips on books that she might find interesting to read in the library. So she kind of had a little bit of secret help from her brother's tutor. But she then started to teach herself Latin. Many women throughout history had to self-teach a language in order to read scientific papers. Further back in history, there were other languages that were kind of had scientific writing published in them, but primarily Latin in this period. So she was doing both of those things. Now, luckily, her uncle was Dr. Thomas Somerville. When he found out that she was teaching herself Latin and trying to kind of acquire some scientific learning of her own will, he basically really encouraged her, and he helped her along with her Latin to improve that. And he also assured her that this was a path she could do, that there had been many women scholars before her. So even though the education system was against her, there was still a way that she could go forward and actually do something useful in science. So it's really good that she had the support of him. When she got married to her first husband, he was very much not in favor of women being educated and tried to block what she was doing. But she married Dr. William Somerville in 1812, and he was way more encouraging and really helped her with the studies that she continued to do. And she ended up, as well as learning for herself, she was tutoring other people, and she became a maths tutor to Ada Lovelace. Ada Lovelace, of course, was known to Queen Victoria and Albert. Many people knew Ada Lovelace. It was actually Mary that taught Ada Lovelace. So in addition to that, she was still continuing with her own studies. She really loved astronomy, and she ended up having a really illustrious career in astronomy, but she became really well known because she took the 5 volumes on algebra that was written by Laplace. 5 volumes of algebra is not something that is generally kind of digestible to the general public. She rewrote those and just basically displayed them in a way that made people be able to understand what Laplace was talking about, and bringing that into the common language and putting it across in a way that people could understand kind of made her a household name. It's kind of like what Brian Cox does with difficult physics stuff. He can explain it in a way that's easy to understand, and you feel, oh, I do get physics after all. And that's what she did. So she became really well known for that. She published loads and loads of books on astronomy and maths, but she also did a lot of geography and published books on that. And she also had a brief period where she was dabbling in microscopy and also published a book on that. She was said I saw written that she had said she regretted writing the book on microscopy. I'm not sure why. I love microscopy myself. I have 3 microscopes, maybe 4 microscopes. So yeah, I think it's a really fun thing that a lot of astronomers seem to get into. So she became very well known and obviously very learned, and she became so well known, in fact, that in 2017 the Scottish £10 note that was issued features Mary Somerville. So last time I was in Edinburgh, I made sure I went to a cash point and took out £10 so that I could get myself one. So Mary Somerville and Nan Shepherd, who was a poet, were the first 2 females ever to appear on Scottish banknotes. So that is a big honor. So that's pretty amazing. So a lot of people will know her name because of that, even if they're not into astronomy. Excuse me. So Maria Mitchell was born in Nantucket, and her dad was a teacher and an amateur astronomer. Their community was a Quaker community, and therefore he educated all of his children, because the Quaker community have this atmosphere of equality for all. And that's in education, in work life, in social life. Whatever happened for the boys happened to the girls, and that's really good. So she was able to get a pretty decent education thanks to her father. She ended up opening her own girls' school in 1835. She went against the convention in 2 ways. And it's kind of difficult to just explain in the modern world what a big thing this was. But in the States in the 1800s, education was still segregated. Even in the 1900s, in a lot of places, education was still segregated. She was like, no, we're not having that. Anybody can come and study at my school. So she allowed non-white pupils to attend her school. So not only was she teaching women science, she was teaching women of color science as well. And if that wasn't enough of the let's break all the stereotypes, she also took her female pupils out to observe at night. It was never expected that women do this, because basically it was considered that the female constitution was too delicate to cope with a chilly night air. So it just wasn't expected. Like even in the 1900s, when women got jobs as astronomers, they were not expected to work at night. Apparently we need our beauty sleep more than we need to observe. So she was just went against all of those conventions and just did it. And I admire her so much for that, because that would not have been an easy life for her. People would have been really against all of these decisions, but she did it anyway. In her own words, she described herself as having a normal level of activity, but with extraordinary patience. And I think that's probably the case for every female that has worked in astronomy in history, because the amount of backlash that you're going to face, and actually even today, some people still do face. So, I think that's amazing. Now, Maria Mitchell actually discovered a comet in 1847, and it became known as Miss Mitchell's Comet. So at that time, she became a household name because of her comet discovery. So Maria Mitchell became professor of astronomy at Vassar. She was the first female professor at Vassar, I believe the first female professor in the whole USA. She also became the director of the observatory, the first female to do so. And she was also doing research there, as well as teaching and all the other stuff. So she was basically doing the professor's job that men would do. But guess what? She was paid significantly less money for doing it because she was female. There's always somebody that has to do it first and have the really poor conditions, but it does then help to change the landscape for the next generation. And the amount of women that she inspired and helped because of her teaching, amazing. But it's still awful that she was paid so much less than the men were. But even today, there is still gender inequality when it comes to pay in most big academic institutes. So it's better, but it's not perfect. She was very passionate about women being advanced in their science teaching. So she actually founded the Association for the Advancement of Women. As I did in part one, if any of these women have a lunar crater named after them, I'm going to show you where it is, if it's on the near side, or just a photograph of it if it's on the far side. And the reason for that is because there's only 1.6% of lunar craters are named after women. So we deserve to go and look for them. And I will get round to it at some point. I'm determined to do sketches of all of the craters that are named after women. So we're kind of at the perfect phase right now because we're at about 54% moon. So when we're at just past half moon, if we look up here near Aristotle's and Exodus, this little crater that's adjoining Aristoteles, that is crater Mitchell. So it's not a huge one, but it's certainly bigger than quite a lot of the female craters that we see. So I'm extremely croaky this evening. So Elizabeth Brown, if any of you are BAA members and have ever delved into the BAA archives, in particular the solar archives, you will be familiar with Elizabeth Brown. She was born in 1830. Her dad was a very keen astronomer and also a meteorologist. They built their own observatory. As I said, most women were not really employed as astronomers yet, but if they were not allowed near the telescopes for a variety of reasons that were listed, but mostly women were not allowed actually in the observatories. But they built their own, therefore she was able to go in it, and she is the first lady to have been photographed in one. I can only imagine how exciting that must be. I know how excited I was when we built our observatory 9 years ago. So for her being the only female probably at the time that had her own, that's amazing. So throughout her dad's career, he kept meticulous meteorological records, and Elizabeth helped him with that when he became elderly and infirm. So she was kind of quite tied with that. But later on in life, she did go off doing a lot of solar observing of her own, and is known to have gone eclipse chasing. She's first eclipse that she actually observed was in 1887. And she stated herself that many women have ample time at their disposal and are often skilled with the use of a pencil. Fair enough. She also stated that the sun is a suitable subject for female study because it can be done in the daytime and didn't necessitate any exposure to the night air. Because as I said before, the Victorians regarded that as dangerous to the delicate female constitution. This is Elizabeth's own words. This isn't a guy saying, don't you go out, it's too dangerous for you. She believed this. Women were made to believe this at the time. And I don't understand why. Something to do with miasmas that they believe came down. I really don't know. But the mind-blowing thing about this, which I may have mentioned in the previous talk, is that a lot of eclipse chasers were female, and that meant that you had to travel around the world in the 1800s in a boat. So you could have any number of ocean storms, horrendous freak waves. You get to some random island somewhere, wherever the eclipse is visible from, there's all sorts of diseases that could get you. There could be any number of political uprisings, hostile attack because they don't know who the heck you are. You just rock up with a telescope. There's all sorts of things that could happen global traveling, especially as a female. There were a lot of husband-wife teams that did it, but they considered that to be less dangerous than for a lady going out at night in the chilly night air in an English garden. And I find it so bizarre. I wonder what these women thought of the fact that ladies just regularly observe at night now, and we're all fine, apart from having a croaky voice. Elizabeth was an amazing sketcher of sunspots, and this is just one of this kind of panel that is in a BAA solar section report from 1893. She meticulously recorded sunspots, and there are endless drawings of hers that are in the BAA archives. So she's definitely somebody worth going and investigating more about because she was quite an incredible lady. Now, Elizabeth Isis Pogson was born in Oxford, where I live now. Her father was the director of the Radcliffe Observatory in Oxford. And in 1860, her dad ended up getting a job in Madras. He became the government superintendent of the Madras Observatory. Isis actually moved there with her dad. There was Isis and a couple of her other siblings, not all of them, but a couple of them actually moved to Madras with her dad. And when her dad passed away, she was appointed director in his place. So I think she was the first person, I believe that she was the first female to be in charge of a government institution like this in India. And if we remember from part one, when Maria Marguerite Winkelmann-Kirsch's husband died, they wouldn't let her stay working at the observatory. They booted her out because they said it'd be a terrible example to set if they let her stay there. So it's really amazing that the Madras guys actually did let her stay and work there. Isis Pogson's name, you may also know, is famous because her dad put her forward to become a fellow of the Royal Astronomical Society. And at the time, they turned her down because of a legal battle over a male pronoun in the founding charter. So they said they couldn't accept ladies as fellows because there were male pronouns in the charter. There was actually a vote asking the members whether they thought we should let women join in. I'll let you guess what the outcome of that was. And one guy very waspishly said that, oh, well, this was practically an invitation to just bring a social element into the meetings. Why don't we lay down a parquet floor and get a fiddle and a pianist and just dance our way through the boring papers? And it's just, what do you even say to that? Firstly, these ladies would have given their back teeth to be able to listen to those boring papers and actually learn from them. But honestly, 20 years later, they did actually start allowing female members, and she was elected as a fellow eventually. But Isis Pogson's name is often known because of the failure of them to allow her to be a fellow at her first application. So moving on to another lady, Mary Proctor. And if it wasn't for the fact that I did a sketch of the eclipse from 2017, I probably wouldn't have been aware of Mary Proctor, I'm ashamed to say. She was born in Ireland, but moved to Missouri in 1881. There are quite a few women that did move to the States because it was easier to get an education in science in the States than it was here. I believe that's the reason she went there. She was taught astronomy by her dad, and she helped him with observations and proofreading of his papers. And together they founded a journal called Knowledge, which ran for quite a few years. She was teaching astronomy in private schools while she was studying herself at university to help pay for the education. And later on, she had a career as an astronomy lecturer. She wrote a lot. She wrote so many books, but she became particularly well known for the books aimed at the younger market. So she was kind of known as a children's author, even though she wrote many books that were not aimed at children. So she became quite well known for that. Now, she's known to have observed solar eclipses, and the reason we know that is because of this beautiful sketch that she did from the eclipse in Norway in 1896. When I got back from our eclipse in 2017, I spent hours and hours and hours trying to get all my different exposures together into one HDR shot in Photoshop. I was having a tough time. It just wasn't working. And I thought, you know what? I'm just going to draw it. I've got all of my pictures. I'm going to just do some pastel drawings of it because that was going to capture what I was seeing with my eye more easily. I did get there in the end. I've done many reprocesses of it, but I did these sketches from photographs. And as soon as I put it online, within a matter of minutes, somebody messaged me saying, your sketch has so many similarities to Mary Proctor. And I was like, Mary who? And I'm so glad that I now know Mary Proctor because she's worth knowing and people should celebrate the work that she did. One thing that we can both tell from these two sketches is that both of them were done under solar minimum because of the order that the corona has. The corona around the sun has ordered streamers, usually 2 or 3 when the sun is not as active. When the sun is very active, the corona is even in all directions because the magnetic field is so churned up. So it's really awesome that there's so much similarity here, and we could both see prominences as well without a H-alpha telescope. So just absolutely amazing. And I hope she's happy that I'm trying to get people to still do sketches because it's so easy to just take pictures now. She does have a lunar crater named after her. So if we look when we've got really good relief around crater Tycho, we've got Maginus down here, and this fairly large crater. I say fairly large, most of the craters named after women are minuscule. So it's a fairly decent sized one, to be honest, and probably doable with modest equipment. So yeah, that's Proctor that's butting up to Maginus. So again, we're kind of heading towards the right phase to look for that one. So yeah, I will get round to doing drawings of all these craters. So, moving on to Wilhelmina Patton Stevens Fleming. She was born in Dundee but emigrated to Boston with her husband when she was 21. They had a child together, and then he abandoned the two of them. He left them. So she was forced to find work in order to support the family. And she ended up getting a job as a maid for Professor Edward Charles Pickering, who just happened to be the director of the Harvard College Observatory. He clearly realized that this was a very bright lady that was capable of better work than just being his maid. Not that there's any problem with being a maid, but he saw something in her, and he would often sort of joke with his staff that my Scottish maid could do better. So he gave her a chance to do better. He first of all employed her as an admin person doing clerical work, but then he ended up teaching her to kind of do some work on the Henry Draper catalogue. So it's often said that Wilhelmina was the first Harvard lady computer, but she wasn't. Nettie Farrar was actually the first. Henry Draper was a pioneer of astrophotography and of capturing spectra of stars. And he was working on this huge catalogue to kind of get all the spectral classes and all the information of all the stars together into one volume. When he died, his very wealthy widow put money to the Harvard College Observatory so that that work could be completed. Now, Charles Pickering did believe these women were capable of the work and employed quite a few of them. But ultimately, the reason that he employed women is because he could pay them less. He knew there was an awful lot of work that had to be done here, and women were capable of it, but he could employ 3 or 4 women for the price of 2 men. So ultimately, it was a money-saving exercise, but he did firmly believe them capable, and he did try to make conditions better for them. But that's how Wilhelmina Stevens Fleming ended up working there. So he taught her how to analyze stellar spectra, and the Harvard computers, the female computers, became known to the guys as Pickering's harem. I don't need to explain how horrible that is a thing to say about a group of women working professionally, but it's what people were up against at the time and even later in history as well. But one of the things that Wilhelmina was doing was devising a new stellar classification system. When you've got stellar spectra of that many stars, you need to start categorizing them more thoroughly. And that's what she started work on. And there were several other people that worked on that afterwards, each of them improving it, but she got started on that. So the reason as well that Nettie Farrar had to leave is because she got engaged, and we can't have women being married and working. That wasn't okay. So unfortunately, Nettie was booted out purely because she decided she was going to get married, which is just shocking, really. But even in the 1900s, there were quite a few professions where you was not allowed to work if you was married. So happy to say things have changed now. There is a crater named after Wilhelmina, but unfortunately it's on the lunar far side, so we'll have to settle for this photograph taken by the Apollo 14 astronauts. Additional processing by James Stubbe, and then I can't resist tweaking any picture that I download off the internet. It's a pretty decent crater. It's a nice size, loads of interesting craters around it. So that'll be a good one to sketch when I get around to doing my female crater sketch catalogue. So another Harvard computer was Annie Jump Cannon. She was born in Dover, Delaware in 1863. She was said to be so friendly, bombastic, amazing sense of humor, amazing to work with. She never got married, so she was able to actually work for longer. Now, her first astronomy teacher was actually her mum, and it was her mum that encouraged Annie to go forward and find a career in astronomy because she knew that she really loved it. So she did get a degree and graduated in 1884, and then started working as a Harvard computer. So she was working on stellar spectra classification again. And in her career, she classified nearly 250,000 stars. So she obviously, when you've got spectra of that many stars, you're going to have to refine your classification system. So she took Wilhelmina Fleming's classification system and redesigned it to fit with as many spectra as they had. Obviously, way more spectral types than they probably thought possible before they had that many classifications. So that's what Annie was doing. So taking that system and making it more to what we're still using today. Somebody else that was involved in that is Antonia Maury. So she was born in New York, and she was the niece of Sir Henry Draper. And I've read that there was a little bit of because she was a relative, they were kind of forced into giving her a job. And some of the other Harvard computers were not entirely happy about this, but either way, they were all doing amazing work. There was enough work for all of them to do. So she actually studied at Vassar under Maria Mitchell, and she graduated in 1887 with honours in physics, astronomy, and philosophy. So again, she was working as a Harvard computer. She was working on the stellar spectral classification system, completely, again, more detailed. And this is kind of the basis of the system that we still use today. That is what Antonia Maury did. But in addition to that, she actually determined the orbit of the very first spectroscopic binary star. So that, again, really, really important work that was being done by Antonia Maury, regardless of whether there was any animosity between her and the other people that were not related to Sir Henry Draper. She also has a lunar crater named for her. So if we look again at the phase we're at now, or a kind of thick crescent moon, down here, it's in an area where there's not a lot of other craters, and it's got this really interesting morphology around it. So that crater really stands out, even though it's quite small. So if you look for Hercules and Atlas, Endymion up here, and just look down, there's this pair of craters here, and it's the first one that you come to with the lovely little wiggly bits around it. So again, that'll be a fun one to draw when I get round to it. So another Harvard computer was Henrietta Swan Leavitt. She was born in Massachusetts and got her bachelor's degree in 1892. When she got a job as a Harvard computer, she was not working on stellar spectra. She was looking at stellar magnitudes. And again, these are the ladies here were working on spectral classification photographs taken by men. They were not expected to work at night. Henrietta Swan Leavitt was looking at photographic plates of stars taken by men because they were not allowed to work at night. But what she was doing is cataloguing stellar magnitudes. And she ended up discovering something. I cannot overstate the importance of this discovery. She discovered that when you look at Cepheid variables, the number of days that it takes them to cycle through their changing luminosity had a relationship to their actual magnitude. So that means regardless of how bright the star is, if you know what its period is, you can calculate its absolute magnitude. If you know a star's absolute magnitude, you know what its visual magnitude is, you can therefore calculate how far away that star is. So suddenly we have a standard candle. We can use this in cosmology. We can look at stars in the far distance and figure out how far away things are. And Cepheid variables are still to this day used as standard candles. This is now known as Leavitt's law. Rightly so, she discovered it. When the work was published, couldn't be published in her name, obviously, because new discoveries couldn't be logged in women's names. It was under Pickering's name. But if you read the blurbs underneath, it clearly states that it is her work. So incredible discovery, and it's really good that Leavitt's law is named in her honor because it was an important discovery for cosmology. She also has a lunar crater on the far side, which has a beautiful central peak and lots of other little craterlets within it. So again, Apollo 14 imagery, because we can't see that from here. So coming back to the UK, we have Annie Scott Maunder. She was born in 1868, and she became the first lady computer at the Greenwich Observatory in London. So she started working there in 1890. And her with her husband Walter, between them, they photographed sunspots daily. Like every day that was clear, the two of them were cataloguing sunspots. She couldn't stay working there when they got married, obviously, but prior to them getting married, they were working together. And one of the things that they observed was the giant sunspot of 1892. So they were doing drawings, but they were also photographing stuff because photography was kind of in its infancy, but taking a picture of something bright like the sun, slightly easier than the deep sky stuff. Between them, they discovered the 11-year solar activity cycle, which is technically a 22-year cycle, but the activity waxes and wanes over an 11-year period. And they also discovered this, what's called the Maunder minimum, where sometimes the solar maximum, the sun isn't as active as you might expect. And there can be periods where solar max is not as max as other times, and that's known as the Maunder minimum. So they did so much important work on solar physics. She became the editor of the BAA journal in 1894, and she did that because she had to resign working as a Greenwich lady computer because she got married. Still shocking to me, quite honestly, that in 1894 is a long time ago, but not that long ago. But yeah, she was still doing amazing work alongside her husband. And this is a photograph, thanks to somebody at Reading Astro Society who knew that there was a picture of this in a book. I finally have a picture of this giant sunspot. So this was taken on the 13th of February in 1892. And this is a pretty huge sunspot that was actually so big that it was visible naked eye. When the sun was low in the sky near sunset, people could actually see that with the naked eye. And this is the biggest sunspot I've ever photographed, and that was from 2014. And I remember how big this one was. I could see this naked eye as well with my eclipse glasses on. So this is not as big as that one that they observed in the 1800s. So yeah, pretty awesome to see sunspots of this kind of size. Really awesome. Now, Maunder has a crater named after her on the lunar far side, and it's a beauty. It reminds me of Copernicus with these big slump terraces and the complex central peak thing going on. This one we can sort of glimpse, although it's on the far side, it is just within the western libration zone. So it's kind of near Mare Orientale. And if you have a favorable libration, you can get the tiniest glimpse of it. You won't see it looking like this, but it is one we can glimpse occasionally. But this is a lunar reconnaissance orbiter photograph of it, so you can see it in all its glory. That's the one I'm going to sketch first when I do my catalogue. Now, the Harvard computers were doing amazing work, and they did have great careers, and they were kind of the first women really to be employed en masse doing this. And there have been books written about them. There's one called The Glass Universe. The glass ceiling is this invisible barrier that women often face where they can't get promoted to more senior levels because the men are providing this glass ceiling that they are just being blocked from getting past. The Glass Universe talks a lot about how these women smashed through that, but they kind of didn't. The work that they did, the discoveries they did, very much went up through the glass ceiling. The women themselves, their working conditions were not actually that great. All of the work they were doing was assigned to them by the men. It was directed by the men. A lot of the discoveries they made were not even attributed correctly to them. Some were, but some weren't. And quibbles over this led to some women actually resigning and having to be enticed back because they were getting annoyed that other people were taking credit for their work. Within their job, there was absolutely no opportunity for further education or any kind of promotion or career development path of any kind. You got that job. At best, you might be put in charge of 3 or 4 other women. That was it. There was nowhere else to go. That was your lot. So I don't see that as breaking the glass ceiling. I see that very much as being held back by the glass ceiling. Additionally, here in the UK, to get a job at Greenwich Observatory as a computer, you had to be a graduate. That came at great expense. Most people couldn't afford that. When a man got a job there, he could do it straight from school without a single qualification. So you clearly didn't need a degree in order to do the work. But if you was a woman, you had to have a degree before they would even consider you as working as a computer, which I just think is so unfair. If you need a degree, you need a degree whether you're male or female. When Annie Maunder left Greenwich Observatory, it was 40 years before another female was actually employed as a lady computer at Greenwich. So it was very slow going in the UK to get women actually doing this work. So yeah, I'm not taking anything away from these women. The discoveries they made, the work they did was amazing, but their working conditions themselves were fairly poor. The pay was quite poor. And although the group leads were trying their best to improve things, the conditions were just not that good. And there were a lot of women that were approached to come and work there that just said, no, thanks, I can get paid better working elsewhere. So it wasn't quite as amazing as people make out, but the work they did, as I say, was pretty good. So until the Bedford College for Women was founded in 1849, and soon after that, Lady Margaret Hall in Oxford, women, although some places allowed them to go and study there, for the most part, women could not get a degree. They were not even allowed in the libraries to go and self-study in a lot of the universities. But even when these colleges were actually founded, women could study a degree for however many years, but not actually graduate. Women weren't allowed to graduate. So at the end of it, they didn't technically have a degree. And that was the case until 1920 for a lot of these colleges. The women did it anyway because they wanted the knowledge more than the piece of paper, but it's just so unfair. They were paying a huge sum of money with a family that was supporting them to do it, and at the end of it didn't graduate. I just find it really annoying. Meanwhile, over in Paris in 1893, Dorothea Klumpke-Roberts actually got a doctorate in astronomy. She was the first woman to get a doctorate. In 1893, a female in England couldn't even get a degree and graduate. So we were really behind on the education front. Cambridge University didn't allow women to take a full degree until 1948. There were quite a few colleges and various universities, but I've singled out Queen's College at Oxford because that's where my husband Mark studied. Until 1979, women were not permitted to study at Queen's College. Now, I know that I am way, way older than my brain thinks I am, but when I was 6, I would not have been allowed to study there as a female, purely because I was female. And I just find that really shocking. And just for context, the Sex Discrimination Act was passed 4 years prior to that. So it took them a really long time to get with the programme. But actually, within a matter of 2 years, they had 50-50 male-female attendees. So, you know, women did just want to get the education ultimately. So going back to the US again, I want to just briefly talk about Adelaide Ames. She was born in 1900. She graduated from Vassar in 1922. She started to study under the new astronomy program at the Radcliffe College, and she ended up getting a master's degree in 1924. She was the first lady to get an astronomy degree in Vassar, so that's amazing. She really, really wanted a career in journalism. That was an absolute non-starter. There is no way that women could have any kind of career in journalism at all. But she was really passionate about astronomy. So she started working as a Harvard computer and was working with Harlow Shapley. And together they were working on cataloguing galaxies, and they were primarily looking in the Coma and Virgo region of the sky, looking at all galaxies that were brighter than 13th magnitude. Once the photographic telescopic technology was there to photograph galaxies, the initial assumption would be that they would be evenly distributed everywhere. But they discovered when they'd finished their catalogue that there was actually evidence of clustering. In 1931, the Finnish catalogue, which is known as the Shapley-Ames catalogue, had nearly 3,000 objects catalogued, and 1,250 of those were galaxies. And that is where they found this evidence of clustering. So that is entirely new research. Nobody understood how or why that could come about, but their catalogue just proved evidence of the fact that there was clustering going on. So galaxies were kind of clustering together in groups rather than being uniformly distributed around the sky. Sadly, when she was just 32 years old, Adelaide Ames died in a freak boating accident, and it was just such a loss. Everybody that worked with her adored her, and it was just everybody was devastated. And it's amazing, like, what a career she could have had she not lost her life so young. One lady that was very best friends with Adelaide Ames was Cecilia Payne-Gaposchkin, and many of you will know Cecilia Payne's name. She was born in the same year in Wendover in Buckinghamshire, but she ended up where she lived in Buckinghamshire. She couldn't get an education as a female, so she ended up moving to London when she was 12 so that she could attend St Mary's College in Paddington. But when she got to St Mary's College in Paddington, she found out that women were not allowed to study maths or science there, which she found incredibly frustrating. So in 1918, she moved to St Paul's Girls' School, where she was able to study physics. She got a scholarship to Cambridge University, so obviously she got her degree, but because it was Cambridge, she wasn't actually allowed to graduate or get the full degree. While she was at Cambridge, she attended a lecture by Arthur Eddington about his eclipse expedition, and that really sparked her interest in astronomy, and that made her decide that's the way she wanted to go. So she did get she completed studying her degree in Cambridge, but couldn't graduate. So obviously that limited what she could do next. So in 1923, she moved to the USA so that she could become a student on the Pickering Fellowship. So she was only the second lady to actually study under that fellowship. In Shapley's group, she's working with Harlow Shapley as well. She was described as one of the most capable go-getters. I don't know why that offends me so much. Maybe it's just a turn of phrase that they used back then, but that just sounds so condescending to me. But she was clearly very, very talented and very intelligent, and she actually became the first person at Radcliffe College to get a PhD. In her thesis, which was described by one of the examiners, one of the best astronomy theses ever written in the history of astronomy, she was looking at stellar spectral classes and relating the different spectral classes to temperature. And in her research, she was concluding that the sun had to be composed of 99% hydrogen. That was not the general belief at the time. Henry Norris Russell was one of the examiners of her thesis, and he basically said, you're going to be a laughingstock if you leave that in. Nobody's going to believe that, because the general belief at the time is that the Earth and the sun had the same composition as each other. She didn't believe that, but she took it out of her thesis anyway, because she obviously wanted to pass and actually get her PhD. And guess what? 4 years later, Henry Norris Russell published a paper confirming her results. Did he credit her? He very briefly mentioned the fact that she might have thought about it, but didn't properly credit her with actually making that discovery. So it went down in history that he had discovered that the sun was made of hydrogen, when in fact Cecilia Payne made that discovery. So I think it's kind of generally known now that she did that, but it really was just not kind to not credit her where it was due. She ended up leaving that field because I think she was so burned by the fact that this guy had stolen her work and claimed it as his own. So she ended up going off studying stars instead. So she was trying to understand the structure of the Milky Way. So she went on surveying all stars that were brighter than 10th magnitude, just trying to kind of understand how the Milky Way worked, basically. And she surveyed over 2 million variable stars with her husband, Sergei Pochkin. That is a lot of stars. So obviously they were doing this on photographic plates. So she ended up having a very successful career in that field. And yeah, the two of them together, absolute dream team when it came to variable stars. At that time, women were still barred from becoming professors at Harvard. So although she was doing this amazing work, she was stuck doing very low paid research jobs for many, many years. She did publish a lot of books, and eventually in 1956 she became the first female professor at Harvard College Observatory, and later became the first female head of the department. And once that happened, it was a real turning point at Harvard, and more women were then given the opportunity to get the roles that they had earned and that they deserved. So again, it was like a tough path for the first lady that did it, and then it was easier for everyone that followed. So amazing, amazing lady. That there's a book been written about her that I have and haven't had time to read yet, but she's a really amazing woman. I can't do a talk about kind of more modern female astronomers without mentioning Margherita Hack. She was born in 1922. She was an Italian astrophysicist and is probably best known for, again, working on stellar spectra, working with Otto Struve. Now, Margherita Hack was a bit of a firecracker. She had zero tolerance when it came to pseudoscience, religion, anything that she saw as not hard scientific fact. She did not pull her punches when it came to kind of battling with people over stuff like that. She became the first female professor in 1964, the first female professor in Italy. And she also became the director of an observatory in Italy, the first female to do so. And when she took it over, it was a kind of unknown observatory. And within a matter of years, she transformed it into this huge research center that had global collaborations all around the world. Absolutely turned it around. Funny story about her. She was very feisty and very opinionated and really truly believed that her opinions were correct. She went on an anti-fascist march, and because of that was told that she couldn't sit her exams at high school. So she almost got kicked out at an early stage, because without those exams she wouldn't have been able to go forward. Kind of not lucky, but sort of lucky for her, World War II broke out and nobody sat exams that year. So her going off on that demo meant that she was able to still have her career. So one good thing came out of the war, but she did have a really brilliant career and was still doing outreach and stuff right up until she died in 2013. And she's a lady that most people haven't heard of, and she deserves to be heard of. So somebody else for you to go and research. Vera Rubin, I'm sure you will all know, born in 1928. She began observing age 10 when she had a little telescope that her dad and her built together. And she was fascinated by all the stars of the Milky Way. So she kept pointing it at that. And she ended up basically graduating in 1948. She was the only astronomy graduate at Vassar that year. Not just the only female, but the only astronomy graduate at all that year. She was barred a graduate place at Princeton because she was female, and Princeton was still not accepting graduate positions. But she did end up going to Cornell and got a master's degree in 1951. She made the first observations of galaxies that were deviating away from the Hubble flow, and she was providing evidence of galactic superclusters. So not just a bit of clustering, but actual huge superclusters of galaxies. And again, evidence that galaxies were not evenly dispersed and evenly kind of spreading out from each other. So really, really important work. She also studied galactic rotation curves, and this is the basis of all work on dark matter. This is the evidence that we have for dark matter, even though we don't yet know what this particle is or what's driving it. We know it has to exist for galaxies to behave the way that they do. And all of that work is basically thanks to Vera Rubin. She was a massive advocate for women in astronomy, so she actually mentored a huge number of aspiring female astronomers and helped untold numbers of women to actually have the career that they wanted. She had many different honors throughout her career, but one amazing one for her is that the Large Synaptic Survey Telescope, which they started to build in 2015, is now named the Vera Rubin Observatory. I am so excited for this coming online. It's got held up because of the pandemic, but hopefully within the next couple of years, this is going to come online. It's in Chile, and basically within 3 nights, it's going to be able to image the entire visible sky from that observatory. This telescope is going to be able to see down to mag plus 25. It's going to make so many new discoveries that there's no way we can even keep up with the data. I mean, it's just so exciting. It's estimated that it's going to make 1 billion new discoveries. It's going to probably increase the number of dwarf galaxies, asteroids, comets by 10 orders of magnitude. It's just going to be so exciting. So very excited about that. It's an 8.5 meter, 8.4 meter diameter mirror with a 3.2 gigapixel CCD. And it's basically for 10 years going to image the entire sky every clear night. And hopefully, the projections at the moment are that satellite mega constellations are going to kill 1/3 of their data, because when you've got something that can see down to mag plus 25, a mag plus 6 satellite panning through is going to flood all of the pixels. So that's going to be a nightmare for them, but still very exciting. Going to be some amazing discoveries made by that. Now, Caroline Shoemaker was born in 1929. And what I love about her story is you will know her name. She began her career age 51 with no previous scientific qualifications whatsoever. She was married to Eugene Shoemaker, the planetary geologist, and when her children had grown up and moved out, she had a bit of empty nest syndrome and wanted something to do. So she began working with him in his lab, and she ended up getting a job working at the California Institute for Technology and the Palomar Observatory. And what she was doing was looking for Earth-crossing asteroids and comets. And the way they did this was taking photographic plates a couple of days apart or a few hours apart, putting the two of them side by side in a spectrogram, and anything that had moved between the two shots kind of looks like it's floating. It's like 3-dimensional. She had a really good knack for using the spectroscope. Not everybody could do it, but she was really fast at it. She made so many discoveries, absolutely amazing. So she also began working at Arizona University, concentrating again on these planet-crossing asteroids. And this was something people were not really taking seriously. And then Eugene and Caroline, working with David Levy in 1993, looking at one of these 2 photographic plates side by side, what did they discover? But 5, not 1 object, but 5 objects that had moved in the shot. And she just couldn't understand what it was at first. They all had a look. They all went to the pub, realized this is a fragmented comet. They ran the numbers, realized that this was a fragmented comet that was going to hit Jupiter. They had discovered Shoemaker-Levy 9, and all telescopes were pointed at Jupiter on the 16th of July. And then these fragments over the next few days impacted Jupiter and left scars. This was a wake-up call. Suddenly, near-Earth asteroids and Earth-crossing comets can and will impact planets, and we need to be looking for them. And basically the work that David Levy and the Shoemakers did is kind of the basis of Asteroid Day and all the stuff that we still do today. So they became kind of a household name because of Shoemaker-Levy 9. Unfortunately, Eugene was killed in a car accident in Australia while they were on a geology field trip, and Caroline sustained some pretty serious injuries. When she recovered, she came back and continued to work with David Levy and continued to work up through to retirement age. She co-discovered 32 comets and about 100 asteroids in her career, and at one time held the record for the most number of discoveries by a single person. I had the absolute honor of interviewing her about a year, 9 months, I think it was, about a year, 9 months before she died. The interview is still on the Comet Watch YouTube channel, and I've honestly never felt so emotional interviewing somebody in my life. She was in her 90s, interview on the phone, and she was utterly lovely. And I'm so, so grateful that I had the chance to talk to her, because I admire her so much. And she shows that you don't necessarily have to have had this kind of glorious academic career beforehand in order to succeed in astronomy, and that's amazing. She did get an honorary doctorate in 1996, and that was very well deserved. So the last lady I want to talk about is Jocelyn Bell Burnell, and you guys will need no information about her. I'm sure you all know a lot about her already, but she was born in Northern Ireland, and her dad was the architect that designed the Armagh Planetarium. So she was visiting the planetarium quite a lot with her dad, and she loved it. And the staff realized that she was really into it, and the staff there encouraged her to have a career in astronomy. In Ireland at the time, basically women were educated to the point that they could then leave school and go and get married and have children and be housewives. There was no expectation that women would have any career of any sort. So she faced a real uphill battle. When she went to university at Glasgow, she was the only female in the honours physics class, and basically there was a tradition that when a female walked into a lecture room that she'd be catcalled and desks banged and feet stamped, just utterly humiliating, and everyone assumed she would leave, but she didn't. She stuck with it, thankfully. She went off to Cambridge to do her PhD, and there she designed and built the radio telescope array to study quasars. And one night on the 28th of November in 1967, she noticed a little bit of scruff on the trace. The trace was still a piece of graph paper with a pen, kind of looking at stuff. She then spent 3 months going back through all of the historic, like literal miles of paper to discover that this had happened before in a cyclic way. She had discovered the first pulsar. So obviously this had a lot of media attention, and it earned a Nobel Prize. She was not the recipient, her supervisor was, but she always famously said that she felt it would demean Nobel Prize physics if they were awarded to research students, except in exceptional circumstances. She did not believe that she was an exceptional circumstance. I disagree with that, but I think she's amazing. But what really shocks me about this story is it obviously had gained a lot of media attention. And when the press came to interview her, even though she designed and built the telescope, they asked her supervisor all of the questions, Anthony Hewish, and he answered the technical stuff. When they got to her, did they ask her about how she got into physics? No. They asked her what her bra waist hip measurement was. They asked her if she was fatter or thinner than Princess Margaret. And how many boyfriends did she have? Obviously, that's a crucial bit of information for a scientist to give the press. And also, they asked her when they were taking photographs if she could unbutton her blouse a bit so they could have a bit of cleavage on the photographs. And it's so horrible. I cannot imagine how humiliating that would have been for her. She's worked as a lecturer and research in loads of universities and had so many awards throughout her career. If you've ever met her, you'll know what an amazing person she is. She's very quiet, very determined, but has done so much good to help women in astronomy. In 2018, she got the Special Breakthrough Prize in Fundamental Physics, and she used the entirety of the £2.3 million prize money to set up the Bell Burnell Scholarship to help female minority groups and refugee students who wanted to study physics and become research physicists. Just amazing, absolutely amazing. She was also involved with the Athena Swan Awards to help with female friendliness within departments that had a big kind of disparity, male to female. She was also heavily involved with the Let Toys Be Toys campaign to take away the gender stereotyping on any scientific toys, because prior to that, anything that was a girl's toy was in the pink dolls aisle, everything else was boys. So they've done so much work to make that better. So that she's done so much work to try and help get this disparity sorted out. I was on the bill talking at the FAS conference in December 2022, and this wonderful young lady was one of the Bell Burnell scholars, and it was just such an amazing thing to be a part of. In the UK, the data on the IAU at the moment, their website in terms of breakdown by country doesn't go beyond 2021. In 2020, the UK were at 13%. In 2021, it had gone up to 17.5%. So it has improved a bit. This is not all the countries, by the way. It's just a kind of a breakdown of just a random assortment across the board. We are still below the world average. It is getting better, though. So the IAU global female membership by age range, if this is across the whole world. If we look at this, we can see that in the younger age groups, this is as of December 2023, I believe, looking at their data on the website, we're kind of getting up towards high 30% here. We're nearly at 40% in these lower age groups. Then it starts to drop down quite sharply in the upper age groups. This can be interpreted in two ways. Firstly, younger women are getting more opportunities. That's definitely true. If you look at how many females are doing PhDs and postgrads in physics and astronomy, it's definitely increasing. However, if you look in the senior roles, you won't find very many women. There's still a huge disparity. Is that simply going to get fixed by all of these people having an opportunity, or is the glass ceiling still in place? Only time will really help us to answer that. But it is good to see that these figures are rising. And when you go to conferences, you see more and more women at these things all the time. So that's amazing. Any females watching this, we all need to be a mentor if possible. If you ever get asked to do something for Beavers or Cubs or Scouts, please say yes, because you don't have to have a master's degree in astronomy to inspire the younger generation. Mostly you have no idea who you've inspired. I've been lucky enough to talk to people who have continued and done this professionally, thanks to seeing me do a talk. They now know more about astronomy than I do, but all they need is a girl to be sitting in that hall and see a female doing a talk on astronomy, and it makes them believe they can do it too. So any opportunity we have to do outreach, please say yes, because we need to be the role models there. This book came out in 2022. It's written by women astronomers about their journeys. It's not all beaten horrible people that tried to block them. There are actually a lot of really lovely, heartwarming stories of people that helped. So it's a really nice read. And there's no author here trying to put a spin on it, trying to sell a narrative. It's all in their own words. Shameless plug, last year I worked an insane number of hours co-writing the Colin Stargazer's Bible with Ian Ridpath. Amazing opportunity. That is now available for pre-order. That's coming out in September. So very exciting to have a book that I've actually co-authored for the first time. I want to just leave you with this thought. We have gone huge ways forward now, women working within the workplace, in academia, etc. But where we're falling behind is getting the equality in the home. And this account, Mums Behaving Badly, shared this tweet, which I think is actually sobering. There's an entire generation of women out there who are drowning because they were raised with traditional gender roles while being empowered to be independent. These women are still doing the majority of household duties while simultaneously killing it in the workplace. They're tired. We need to do better at home to get that equality right. There are a great deal of high-profile female astronomers who only have their career because their husbands have had to give up theirs to take on the house role. So women at the moment are expected to kind of do it all in a lot of situations, and we need to work on getting that better. So I will stop there and see if any of you have questions. Thank you.
Thank you, Mary. That's fascinating. Can we thank Mary for that before we move on to questions, please? Some interesting stories in there, some of them quite shocking, actually, aren't there? Has anyone got any questions for Mary? Peter, are you going to monitor the chat on that? Peter's quiet. You can put your name in the chat if you've got a question, or you can just pipe up just now if you want to.
I'm still here.
Okay. I don't have any questions about that.
Don't see any at the moment.
Okay.
How about YouTube, Will?
Andrew, I think, has his hand up.
Who was that? Sorry,
Andrew Mackey had his hand up.
Andrew.
but
Yeah,
still
go
on
ahead,
mute.
Andrew.
Andrew's muted, I think. Andrew, you're muted.
Oh.
Looking for the button.
Yeah, they keep moving the button, don't they, with every
Oh,
update?
hi, Julian. You go ahead, Julian. You've got your hand
Hello.
up.
I was looking at that graph where there were, it showed the percentage in the of women in the IAU, and as you said, it started high, it went up, and then it got to 95 to 100, and it went up again. Does that mean that women astronomers live longer or something?
Pretty much. I think it's basic because most women do actually statistically live longer. So I think it is.
Yeah.
Yeah. I think when you get to that end, it's a fairly small number. So the percentages start to become a little bit meaningless. It's like some of the places that have really high percentage male to female. It's because there's only 5 people that work in that country as an astronomer. So you've got to be quite careful with the data when you're looking at small numbers like that.
Yeah. Okay, thanks.
Am I speaking now?
Yes, you are.
Yes.
Go ahead, Andrew.
Oh,
Yes.
well, sorry about that. Mary, thank you. In terms of number of facts per minute, you must hold the record. In terms, I sent a gift of spaceman and space pajamas to a niece of mine with a note with a very quick list of maybe 10 or 12 ladies in astronomy and spaceflight, and you've left me just so far behind. It's a delight to hear it. One particular point, please. You refer to some of the ladies as computers. Now, I'd never heard of humans called computers until I watched the film Hidden Figures, and clearly it's a very old expression. How did you come up on it?
Yeah, it was a name that was given to them because they were doing calculations. So originally they were doing mathematical calculations, and therefore they were called human computers. And it was the same. There were men doing that job as well, but obviously the lady computers were the ones that were kind of breaking the mold and doing it different. So they were purely called that because they were literally doing calculations and the long-handed way. Before, like now, hardly anybody manually does calculations.
I suppose. I'm amazed that I'd never heard it used in that way before I saw the film.
No, it's a strange one. Until I was reading about the Harvard computers, I hadn't heard of it either. It's certainly not something we use today, is it?
Thank you.
It was used in the days of Bletchley Park as well.
Yeah.
Ah, right. Okay.
Still never been there, and I don't live that far. I really need to go.
Yeah. Well, they were doing calculations. That's right. Yeah. Okay. And that may explain why we used to speak in the early days about electronic computers as opposed to human ones. Anyway, thank you.
They were like the size of a house, though.
Are there any questions?
Will, anything?
Anything on YouTube, Will?
No, there's nothing from YouTube, but absolutely fantastic talk, Mary.
Thank you very much. Thank you very much for that, Mary. I have to say, my experience, I studied astronomy at university, and my experience is quite the reverse. There were 5 of us in our single honors class. There were 2 males and 3 females, so we were overpowered, and they were the bright ones.
Yes, there's still something that happens when you do talks to groups of mixed children in a primary school. Everybody's into it, everybody, but something happens at high school age that puts girls off taking it forward. And it's really hard to pinpoint what it is that's happening. And I don't particularly agree with segregated education, but it's been proven over and over again that going to an all-girls school makes girls choose maths and physics more readily than if they're in a mixed school. So I don't know if it's peer pressure or what is going on, but like everybody that studies this will tell you that something is happening around age 13 that is making girls not have the confidence to go forward. But those that are in all girls schools do have the confidence to go forward. So I know teachers are working really hard on promoting STEM subjects, and it is having an effect, but something is still happening at high school that's putting girls off. And mean, I experienced so much prejudice at high school. It was unreal. I had one of my best male friends, bet me £10 that I was going to fail my maths GCSE. And that was a friend, right? So it's kind of, so I'm like, right, I'm going to prove to him that I can do it. And I did really well to prove a point. And I never did get my £10, but but that kind of, so because I had such a supportive family with whatever I was going to do. If you have a family that are a bit indifferent and then you're getting picked on at school for being too stupid because you're blonde or whatever, it's going to get in there. And I think, you know, it might just seem like silly childhood bickering and bullying, but it can actually really start to impact people. And then you see the gender stereotype, like pajamas. If you go on Amazon now and look for space pajamas, they're all labeled as boys, even age 3. Yeah. And exactly. Boys and girls are the same shape age 3. There's no need to call them boys' pajamas. So it's stuff like that that is changing now and getting better. So hopefully it will continue to improve.
Good. Okay.
Francis put an interesting comment in the chat. I don't know you, Francis, are you there?
Oh, thank you for that comment, Francis. Yeah, I get really angry about some of these injustices, actually. Way more angry than I probably have any right to, because I didn't know the women involved. But the thing that happened, like at the Berlin Academy of Sciences with Maria Kirsch, it's outrageous. It's so outrageous. And she ended up not being able to have a career in astronomy anymore, purely because they kicked her out after her husband died. And it's like, why? I don't understand why. It's just, I do get really emotional myself when I'm reading some of these stories. And honestly, when I read Caroline Herschel's memoirs, I bawled my eyes out so many times at the way she was treated by most of her family. It was just appalling. But then there's that idea of, if she hadn't been treated like that, would she have done as well as she did? Because she really had something to prove. Who knows? But you know, just I cried so much reading Caroline's memoirs.
Well, thank you again, Mary. Can we thank Mary for a really excellent talk? Thank you.
Thank you.
Okay, shall we go to Spain? Ian, do you want to drive? I will share the screen and you can drive if that's all right with you. Can we all see that?
Yes. So I've got M45 lined up, ladies, with the expectation that the moon will be nearby. Is that what you were thinking of?
It is, yeah. The moon will be blaring out and hiding the Pleiades, presumably. Let's give it a shot and see what we can find.
So hold on a second. Just need to stop imaging. Back to framing. Slew in center. So the scope is slewing at the moment. Still getting there.
Yeah, nice smooth guiding graph. Half an arc per second.
Yes. So it's taking its first image to see if it's where it should be.
Uh-huh.
It may not be able to plate solve that.
Yeah, it has done, yeah.
All right, very good.
Nice reflection as well.
Yeah. So it's about to try again. And
that will be the field flattener, the reflection.
It'll be what, sorry?
The field flattener.
Ah, yeah, could be.
I have that with mine.
Yeah, it is very bright. Oh, we can see the moon, and I presume that's the Pleiades there. Just
yeah, that sort of looks like them there. But we can it can't guide at the moment because it's too bright. So
do some different exposures, see what we can find.
Yeah,
and loop it.
Surely you don't need guiding at those exposures.
No, we don't. No.
It just did it automatically. Right, here we go. So we'll start by 1 second, I suppose, just to get an idea. Pretty bright too.
Yeah, sorry, just get save off as well. Yeah.
Yeah.
Well, we can see them both. You can see the Pleiades on a very bright moon.
Yeah, I've just turned it down and maybe I need to stop it and restart it.
I remember how hard it was imaging Venus and the Pleiades a few years ago.
Yeah.
A bit less. Pencil a second. Sorry, 100 for a second. Still bright.
Yeah, it's still very bright, isn't it? Oh, actually, we need to turn off the magic. There we go. It was auto stretching it.
Yeah. Oh, right. Okay.
So now we can see the moon, but not the Pleiades. Yes.
Yeah, Pleiades have gone. So yeah. It's
Put that back up to a second again and see what happens. Well, there's a lesson. You cannot image the moon and the Pleiades at the same time.
That's what Photoshop layer masks are for.
Yes, that's right.
So
Hey,
yeah, you can see them there.
Yeah,
And well, you can see the craters.
yeah, quite nice.
Yeah.
Terminator as well. That's really rather nice.
That looks like one of Galileo's drawings now.
Yes. Well, there's a sort of the Subaru shape, isn't there? You know, the tail pointing downwards.
Mhm. Anyway, it found it quite easily. Which,
Yep.
It's quite pleasing.
Yeah. Yeah.
Was a fabulous shot of the Pleiades at the start there, Ian.
Say again, sorry. I missed that.
I was
Sorry.
saying it's a fabulous shot of the Pleiades at the start when you were
Yes.
imaging.
Yes.
Yeah.
Thank you.
I think that was up about 1 second or something.
Yeah.
Are you talking about the composer, Nina? That was not a real image. Oh, but this
yes,
is good.
quite.
Yeah.
The
Oh, this is
framing one, yes, framing was a gem.
Yeah. But there was no moon in that one.
Yeah. Let's see how we can bring out the Pleiades and ignore the moon.
There's a bit of earth shine there.
Yes.
Yes. Well, yeah, there is.
No, that's not real. Didn't you know? The moon actually changes shape according to some people.
Some fusion going on there, I think.
Yeah. Very bright. Well, there we go. We've seen the moon close to the Pleiades. I think that's all we were hoping to see. Yeah, you can see the earth shine as well, yeah. That a star on the edge there, a couple of stars.
Yes. Yes.
I think that star is HL24, and by my calculation, that's going to be a grazing occultation in a few minutes' time.
It's gone. That one at the bottom, right?
No, it's on the left hand side.
Right, okay, right.
The one near the edge there.
Yeah.
Right.
It's part of the Pleiades?
Yep.
Yeah.
I think it's going to slip as the moon goes across. It grazes behind the, if you like, the cusp of the Terminator, and disappears for about 10 minutes, I think.
Interesting.
The star is magnitude 7.8.
Okay.
and I have it disappearing in about 5 minutes' time.
All right. Okay. Well, we can stay on for whoever wants to watch it. Anyone who's had enough, you want to go. Keep it running. The craters do make an interesting.
It's also a double star.
Uh-huh.
Right.
So when you
Maybe not.
the companion is magnitude 13. So
Unlikely.
when you do get a bright double star being occulted, then the brightness, total brightness, drops in stages, of course. As first one of the double is occulted, and the next one. They stepwise decrease in brightness. I reckon about 2058 for the occultation, but that's just a rough estimate from just playing it through on my planetarium.
Okay. Well, I'll leave it running, and you can watch it. I don't think there's much else to say about it, but the Pleiades stand out quite well. The other things we've been imaging tonight, let me show you some of the pictures, are a couple of comets, so 12P Pons Brooks and 29P. What's 29P?
I remember that.
And we've also captured a supernova, we hope, an NGC 1222, which is really bright at the moment. And we've been monitoring a dwarf nova as well, which is not in major outburst at the moment, but undergoes periodic variations.
29P is Schwarzmann-Wachmann.
That's the one, yep.
There's loads of outbursts, isn't it?
Yeah, there are loads of them, that's right. The BAA monitor that one very regularly, in fact, all the time, because it never really goes away, does it?
No, it's kind of weird as comets go. Its orbit's quite unusual.
Yeah. Oh, it's gone. Just
gone.
Winked out of existence.
Yeah.
Wow.
I saw
That was very instantaneous, wasn't it?
Nearly almost 2057.
Yes.
Well, this is Spain, of course.
Well, I'm doing this for Spain. It's all right. I've got the right
Okay.
coordinates.
All right, okay. Good. Excellent. We can pop over to.
It misses it altogether from here.
All right, okay. Well, there we go. That was one of the Pleiades. We'll just pop over to the other telescope and have a look at some of the images we've caught tonight. What's this one doing at the moment, Ian? That's
Well, it's paused at the moment, but it's the UM.
the dwarf nova in a major,
Yes. Yeah.
which is not very interesting. It's that one, but we will do some processing on that one. What else have we caught? That's still the same one.
Couple of comets.
Yeah, so this comet here is 29P, which seems to be very close to the moon, I would imagine, which is why we've got the there we have 29P Schwarzmann-Wachmann.
Our Comet corrector isn't working well at the
No,
moment.
it's not. No. We are getting that replaced, as I mentioned before. This is the supernova, is that right?
Yes.
Yes, it is. So that's the galaxy, which is the supernova. Let me just check that one out. It actually might be the bright one here, in fact, because it is actually a lot brighter than the galaxy itself. That's the comet. What's down there? Yeah, so that is the galaxy, and that is the supernova, I think, which is brighter than the galaxy itself. So one star in outburst, brighter than the whole galaxy of 100,000 million stars. Am I right there? 100,000 stars. What's it? 100,000 billion? 100,000? 100,000 million. Yeah. Think of that order. It's quite amazing. And then we've been capturing Comet 12P, which is slightly off center, which is getting brighter as it approaches perihelion in the summer, but it won't be visible for us at perihelion. We'll be losing it then. Okay, that's probably it from us for tonight. Thank you for joining us, and thank you again, Mary, for that. It was really, really excellent talk as always. We'll hopefully see you back again sometime.
Thank you. Have a lovely weekend.
Yes. Okay. Thank you.